So welcome everyone to, unfortunately, the last session for today, so regular session. Of course, there's afterwards the dinner and the chess and also the evening talk, so look out and don't miss it. But still, we have another highlight. You can see here Ben. So ladies and gentlemen, it's my pleasure to introduce you our next speaker, Mr. Ben Holmes. Originally, he's from Charleston, South Carolina, and he's holding a bachelor degrees in computer science from Georgia Tech. And today he's a noteworthy figure in the world of software development, especially in the area of front-end web development. As you can see, Ben is connected remotely to us. So he's at the moment in the US, and we are happy that he's here. So at the moment, he's a full-time software developer, open source developer at Astro, but actually this does not limit himself to his role. So he constantly shares his broad knowledge and teaches others aiming to continuously create tools that help anyone interested in this field to become the best version of themselves. He's very well known as a creator of the popular Whiteboard, the web video series, and he's a top 500 author on dev.to. And this is where you might know Ben from. So he uses all these kind of platforms to simplify complex technical concepts, to make technology more accessible across different skill levels and backgrounds. Today, he will be sharing with us his thoughts on opt-in design, the new era of web frameworks, which is an emerging trend that is reshaping the landscape of web development. So he will guide us in exploring these cutting-edge design trends and discuss their impact on workflow and web performance metrics. So if you have any questions during the talk, please write them down in Slack. We will collect them. And of course, after the talk, if there are questions in the room, we can hand over the microphone. Last words about Ben. So if you look at his website, he writes down there 3 significant values. They are be caring, be clear, and be casual. So with these words, I hand over to Ben. Thank you very much for being here today, and we are very looking forward to your talk.
Yeah, I mean, thank you so much. That's probably, and applause. My God, I've done nothing. But yeah, thank you all so much for coming out. Probably the longest and nicest introduction I've gotten. So thanks for the warm welcome. And sorry to join y'all virtually. I'm happy that y'all are attending. If I heard it was a virtual talk, I might have gone to something else. But I swear, this is going to be worth your time. So I'm going to screen share right here. And we're going to jump into it. So this talk is about opt-in design. I'm dubbing it a new era in web development, a new way that we approach web frameworks as a maintainer myself. And as someone who is probably overly connected to everything going on in the space, I feel like there is sort of an overarching narrative that you can take away for any tool that you use, no matter the stack. So first off, to define what I'm talking about here, it's not a UI design talk. Graphic design's my passion, though, clearly by this slide. It's also not a systems design talk. We're not talking about UML diagrams and databases. We're talking about API design. So learning what good defaults mean when you're building anything from a full-scale open source library to a component in your company's design system, choosing the best sort of default behaviors so that users fall into a pit of success, and helping you both find and build the best tools for everyone. So whatever your team's background is, whatever y'all's preferences are, I think there's some, overarching takeaways you can use that should cater to everyone. So introduction of myself, I feel like we've already introduced everything. I'll run through this quickly. I'm a core maintainer at Astro.build, which is a web framework for building fast content-focused sites. I'm also unofficially the chief whiteboard officer. It's not an official title. But if you go to wtw.dev, that's where I post an archive of all of my videos. I do short form content explaining on a whiteboard like this one. We'll get to that. Concepts around the web development space. And I'm the champion of content. I love Markdown, MDX, MarkDoc, working with local files in order to publish something on the web. That's the stuff that I maintain at Astro, and it's what I've been passionate about for a long time. So first off, I start with a show of hands. Has anyone here used React.js before? And I'm unfortunately going to show you yourselves. So yeah, that's a decent percentage, I think. So keep your hands raised, keep them raised if this has happened to you in your React.js journey. This effect right here. Surprisingly few people there. Interesting. Usually more hands go up than we started with when I show this slide, but this is an example of use effect which, well, if you don't use it properly, you forget your dependency array, you can cause infinite loops in your application very, very easily. And also, has anyone Googled this before? Show of hands if you've ever searched for use memo or something about that. We have that one dude in the corner. He knows. He's battle tested before. The rest of y'all, trust me, you'll get there. But in React, you also have to be very smart about what runs when. And you'll probably deal with a lot of blog posts wondering about best practices because it's been around for a long time, but the defaults aren't exactly what you would expect. So this is based on a principle in React I'll call re-rendering by default. And React team might call this consistency. I've actually spoken with Dan Abramov about this. They love the term consistency, which means when you have state and you want that to affect the UI that the user is seeing, you want to make sure that the state and the UI are always aligned. No observables, no sort of like waiting and updating DOM elements. When you write a component and there's a variable, and you use that variable inside your UI, you want those two results to be very tied together. And this makes for a very easy mental model that gets harder at scale. So this is a basic code snippet you might see on an e-commerce site. That's my background personally. Here we have a shopping cart component, which might need to track a few things. First, you might want to track the quantity, how many things the person is purchasing from your e-commerce site. And you might need to compute some state values based on that state. For example, the price, you might have a calculate price utility that takes in the quantity and spits out a price that should be displayed in the UI. And you have a text input in order to update that quantity. Or maybe it's like a button input, however you set that up. So whenever you update state or you type something in that input, it's going to call set quantity. That's React's getter, setter pattern. That will beam up here and tell React, rerun this function top to bottom. React is very naive about this, where if you modify any state variable inside of a component function, it's going to run your function top to bottom and every little thing that function contains, no matter what it is. So it goes back to the top of the component, sort of reinitializes that state variable with a new state. It reruns your calculated price function right here, and then it returns all of this new UI. And it'll do some diffing in order to make sure it only updates the parts on the page that changed. Maybe the text input didn't change, but the cart did in some way, but it will still do all of the work to render it. So let's say we hoist up this quantity a little bit higher in our application. React has a context pattern that lets you hoist state higher in your component tree. So if you're unfamiliar with how React does components, it is going to let you write functions that return little bits of UI, and you can compose all of those functions to return larger and larger chunks of UI. So in this example, we sort of zoomed out from our shopping cart component and said, all right, where's that shopping cart component rendered? Well, it's rendered next to the product images, the navigation bar, and some other parts of our application. And you might need to pass some state to multiple levels of that app. So the shopping cart cares about the quantity. Maybe product images also cares about quantity. So you create this quantity provider that sort of stores the state up here in order to give access throughout the application. And you might need to raise it a little bit higher. Maybe you have a cart provider because you have a flyout coming in from the side, and you want to make sure that the navigation bar also has access to that state. So you hoist your quantity up here. And maybe you go all the way up to the provider. This is global state. If you've worked with backend applications and singletons, kind of like the singleton, where you're storing everything in a global hierarchy, and everything from the cart flyout to the legal text and footer is going to have access to that state. So I sort of call this Momo state, Momo problems. I'm also going to make sure I'm still screen sharing. Yes, that's always my worst fear is I tab away and y'all can't see what I'm talking about. But this is where we get into, some efficiency issues. So if I go back here, I didn't fully explain this, but when you hoist up state in React, it's going to re-render every part of your application that may or may not need to re-render for that state. So when we update our quantity and we hoist it to this global provider, everything from the cart flyout to the footer is going to recalculate. It's going to do a diffing algorithm, and it's going to update the parts that changed. That can be very expensive, as you might imagine. So if we sort of zoom back down to our shopping cart to see how you would solve this at a granular level, you reach for the hammer known as use memo. And this avoids re-rendering state. It's caching the value so that you don't have to recalculate it again. So in this example, we might need to store product images and shipping text as part of this shopping cart component. And of course, these might be fetch calls to a headless CMS, but they don't care about the quantity at all. They're just images and shipping text. And in React, if you aren't careful, these are going to rerun every time quantity reruns. Remember, it's just going to rerun the function naively. So in React, this might be okay for a small application, but when you get that performance audit back, you see that a lot of JavaScript's running, you need to update it to use memo, which is going to cache that result. And it only reruns when you add a dependency array to say, oh, this cache needs to be invalidated whenever a certain state variable changes. In our case, nothing would change this state. Product images is kind of a one and done fetch call. So we just wrap it in use memo to make sure it never refetches from the CMS in some way. And I refer to this kind of like opt-out design. It assumes a goal, which is I want to get my application shipped. I want consistent rendering throughout everything. So you lower developer friction as much as possible to get you to that end goal. So you give the whole toolbox of everything that you want, in this case, re-rendering, and you use memo in order to opt out of that behavior, to cache values. And this hides complexity at first and gets you shipped pretty quickly. Notice that, we just had to create plain JavaScript variables for our state and cache complexity when we needed it. But this requires you to deal with the complexity monster later as you're building out your application. And I do like to do bit of a whiteboard session for this, so I'm going to make my face big here. I have a mini whiteboard. I have a travel whiteboard. I'm away from home, so I don't have the big one. But, if you go to my YouTube channel, you can find the big one. That's what you're interested in. So I like to draw out the lifestyle or the life cycle of an application sort of as a linear line from the hello world that you present to your user. Maybe it's just your splash page, all the way down to the first big performance audit that your company probably will go through at some point. At least that's been my experience. So in that life cycle, you have a line from top to bottom. You start from the hello world and you go all the way down to the scary audit. And naturally, when you're building an app, you need to choose your tech stack. And you probably want to choose it pretty smartly. You want to start with all the tools that you might need later on. So I'm going to draw a little tool chest here of everything that typically goes into a React application. So, tool chest at the top, typically you're going to reach for, Next.js. That's the big one. I hate to call out names, but come on, we all know what Next.js is if you're in the web development space specifically. I shouldn't assume. But if you use Next.js, that's going to come with a few implications. It's going to come with a JavaScript router in order to make it feel snappy, in order to swap out elements on the fly, but that does ship a bit of, JavaScript bloat, depending on how you look at it. And also with Next.js, you probably need, a state library of some kind. React is good at this, but that, of course, implies the React runtime is going to be part of your application. So that's a cost as well that you need to consider. And also some like caching primitives and prefetching, which comes with Next.js as well, just in case you need it. So listing out those bullets there, you need those as part of your app. And immediately, we are dealing with a bit of complexity overhead. These days, oh, my red marker stopped writing. Well, that's a shame. But these days, when you build a hello world with Next.js, which assumes an application use case, you usually end up with somewhere around like 75 kilobytes for a hello world. That's with server components. That's with the shiny new standards, if you're aware of them. And this, might grow with you. This might actually be a baseline that meets where your end state is. But this does mean, you are getting that cost up front. And then when you get down the performance audit, you didn't really add any complexity along the way. All the complexity was kind of a one and done thing. But when you get down here to the bottom, because you weren't really mindful of everything that you're adding, you're just kind of using what is coming out of the box, you sort of end up around here. I don't know if this crosses country lines, but you've probably heard of that dog that says everything is fine and the world is burning around him. It's kind of what I'm trying to represent here. That's usually what you end up with, where you deal with the complexity later. You don't really audit as you go because you're just trying to get something shipped. And, it comes up as soon as the customers are sort of demanding that it doesn't work on low-powered devices or anything else. So what I like to do in order to be more mindful about what I'm adding to an application and let myself audit the individual pieces instead of the full pie is to just start with a pretty empty tool chest at the start of building an application. So instead of using Next.js and all the JavaScript implications, I do like reaching for something like Astro. Yes, I'm going to shill the company that I work for because I believe in it. But you start with a low-grade static site generator like Astro. 11D and Jekyll are also popular options here. And you add complexity, not at the very beginning, but as you go along your product roadmap journey. So the first step that you might run into is you need to add interactivity to your app. You need some JavaScript. You need to add a like button to your blog, for example. It can't just be static content. So you reach for a simple CLI tool like Astro Add React, or in Vite, you would add the dependency to your npm package and your config. In Astro, it's just a command. So here I'm saying, at the start of my app, I didn't even need JavaScript. Then later in the roadmap, I decided to add React. So that was an opt-in behavior. I was able to add it later. And then you might realize you also need server rendering. That slows down the time to initial byte. It does mean you have to deal with caching now. But again, it's an opt-in to jump over to server rendering for A/B testing, for example. You realize we can't do static content anymore. We need some A/B tests. So I'm going to add Node to my application. So a Node adapter, in order to turn it into a Node server. Maybe you use a serverless function on AWS Lambda. It's really up to you how you deal with your infrastructure there. And instead of dealing with the complexity at the end of the performance audit, you're kind of distributing your complexity out. You're adding it in consciously as you're building your application. So that when you get down here to the performance audit, you've kind of been testing your performance already. You've only been using the parts that your app already needs. And if there are concerns with runtime or JavaScript bloat, well, you were conscious of why you added them in the first place. You didn't add it because it came with the framework. You added it because you ran into the need. So you can sort of come to it with real answers of, it's not slow because we were just using what we were given. It's slow because we need this like button on the page, so we're willing to accept like a 90 on our Lighthouse score, for example. It's never the end of the world when you run into performance problems, as long as you know why it's happening. So that's my basic demo of what I would flip to an opt-in design. So I'm going to run through a code example as well. People do definitely love code examples to also explain this. I'm going to compare the React framework with a new framework on the block called Solid. And to explain what this framework is, since not many people are familiar with it at the moment, it is a declarative JavaScript framework for building fast UIs with maximum control over reactivity. This is a synopsis from Fireship, the second best YouTuber, because I'm on the platform. So this is a comparison of a React component and a Solid component to show the difference in mindset. First off, if you try to sort of do a diff between these two, you'd notice that they're written in very, very similar ways. They're both functions. They both have some JSX in order to render out the images, price, and shipping text. And you also have standalone variables to calculate one from another. So we have that same quantity problem that we had earlier. In Solid, you can track state with a signal. In React, it is just called useState. They are the same primitive roughly, but they do different things under the hood. And you'll notice here I put a little X next to how we've implemented this in Solid. And I'll explain why it's a little bit different in a moment. So I have a working demo of both of these UIs. So we have our product image, which is just this emoji here. We have our shipping text, which is at the bottom. And we have both our price and quantity calculated one from the other. And in this React example, we're not using useMemo. Remember that from earlier. You'll notice that when I update the quantity, everything in the component is going to be blown away. Function is rerun, diffing happens. And you'll see you get loading states for all the legal text and product images, but you will still get your updated price. So it is being very eager with all the updates that it does, and you need to opt out if you run into performance problems. Solid is much different, though. You'll notice in this example, product images and shipping text are a one and done thing. Once they're calculated, they are not rerun. It will not rerun your function top to bottom. But you also notice the price doesn't even update in line when we're running this. And that's because, well, you need to tell Solid when one variable depends on another. And this is accomplished with a simple arrow function that you can execute inside of your JSX. Here, if I just add an arrow function to tell it re-execute whenever a dependency changes, the compiler is able to track that quantity as a dependency and reruns this function appropriately. You notice that now my price is updating as expected, But all these other non-functions like images and text are just staying stationary. And that's really the mindset difference, where React is going to rerun where state is declared, which is inside of this component, while Solid reruns where the state is used. So here the state is just used inside of this price element. So instead of rerunning the whole function to see what it returns, it's going to track all the dependencies from the base element level. It's going to see that price depends on some other quantity, and it's smart enough to just re-render this paragraph. No diffing algorithms, nothing fancy, no virtual DOM either. And that is a really nice feature. So we did add a little bit of complexity here to be aware of what is being recalculated, but that has the obvious benefit of when you're reading this component top to bottom, you know what's going to run. You know that this is able to rerun and these other ones are going to remain stationary. You're more conscious about the complexity that you're adding to a component. So this is part of a new wave of frameworks. Remember, I promised this is a new wave. Pretty much everyone outside of React is using a model like this. In Vue, you have computed in order to accomplish the same thing. So instead of an arrow function, you would say computed. And in Svelte, they have this handy $ operator. They went fancy with the syntax that says whenever you put a $ on a variable declaration, that also means track dependencies, rerun when it changes. So same principle, but a little bit of a different shape. We're all thinking about it in the way of bias towards static content, since that's going to be most performant, and then add opt-ins in order to allow JavaScript to rerun. So we're switching opt-out to opt-in. We saw it at the framework level on the whiteboard. We saw it at the component level with our code. Let's break down the principles that define all of these examples. So the first one is finding the lowest common denominator in whatever you're building. The second is to make complexity easy to add only when intended. So use flags that a developer can understand and read in a code review. And stay user first. It is about good developer experience, yes, but the end goal is shipping a product that the user can use in a very accessible, performant, secure way, whatever metric you need to optimize for. So breaking those down, lowest common denominator, think about what the simplest use case is for whatever you're building, whether it's a component, a framework, a library, doesn't matter. And the example we've gone over is, if you're building a React application, the simplest possible use case is rendering some HTML to the page, just showing that hello world, that MySpace, hey, this is my name and these are my favorite artists. That's the simplest website that you can build. So try to design APIs that make that experience super efficient, and anything beyond that experience is an opt-in that you're able to understand. But be conscious about, what that lowest common denominator is. It's easy to build a car with opt-in wheels where everything is a plugin and the library is almost useless without installing some external tools. So you might want to have that standard library, build some things in that are no-brainers for developers, but be conscious about how they add them and what switches they pull. The second one is making complexity easy to add when intended. So don't start with the kitchen sink like our whiteboard example of the infinite toolbox. Don't start with all of the tools available so that you don't understand how to improve performance later. And use flags that are easily readable. The $ wrapper is a well-understood primitive in Svelte. So if you're working with other Svelte developers, they know what that $ means. They know that it's adding re-renders to the application, so that if they notice, oh, there's a lot of $ in this component, a lot of stuff re-renders, maybe you consider a refactor, maybe you look at it a different way. And the last one is stay user first in whatever you're building. Low complexity baselines usually mean better user experience because you're just shipping less to the end user. Now in browsers, this is especially important. Mobile app devs, they get away with a lot of stuff. You can install a 100 megabyte bundle and people don't really care. But on the web, every kilobyte counts, especially when it's JavaScript. So you need to be smart about that response time, cold starts on serverless environments, all of that factors in. And on the web, usually if you have like opt-in re-rendering, for example, that means fewer CPU cycles, better performance on that bad internet connection, on that old Android phone, on that iPad in your desk drawer. All of that stuff is in mind. But performance isn't the only metric. I actually have another example that sort of talks about all of the user-first metrics you optimize for. Performance, security, all of them. So world of examples, we've been through a few of them. I also want to bring up this one from Dino, which brings opt-in design to permissions of an application. I've also learned that Node 20 is adding this feature too. So they're definitely inspiring a new trend here, where when we run a script, in this case, I'm running a server, just basic development server, you need to allow access to certain parts of your device where you're running that app. So in this example, we need access to the network. So we need to explicitly allow network access from the script. We need to allow file system reads, and we need to allow environment variables. None of these are available by default, so that when you run a script, you can sort of lock down permissions and prevent it from reaching out in areas that you didn't intend. This is almost coming down from the mobile application side, where when you install an app, you know all those pop-ups that say, this app wants access to your contacts. This app wants access to your profile in some way. Whenever you have those pop-ups, those are opt-ins to allow the app to do more behaviors. And now we're bringing that to back-end scripts written with JavaScript. Kind of a long time coming. I'm happy that it's finally here. So how does it address those three core principles we talked about? Well, it definitely addresses the lowest common denominator. The simplest case for a Dino script is just a CLI tool with no I/O. Think about a text adventure game, for example, where you just need to walk through a bunch of steps and you don't need to reach outside of it and affect I/O on the system. And it is additive complexity. The flags are describing what needs to be added. In a performance review, you see whenever a new flag is added, oh, my Dino script needs access to more things. And I'm being very conscious about all the things that it has access to. It also does have an allow all flag. I recommend not using that. It kind of defeats the purpose. Be conscious about all the flags that you're adding. And the last one is, it's user first. We're trying to minimize security vulnerabilities. When you download whatever script this is, or we're running it as a backend on our CI application, maybe we installed it as a package and we don't trust the third party, all of that can be controlled by us when we execute the script. And the second one, Astro. Who's surprised by that? It brings opt-in to client-side JavaScript, among other things, but client-side JS is our bread and butter. So we have a template example here where you can, rely on components if you need to, but the default is static HTML with 0 JavaScript. So when you write an Astro template, renders whatever HTML it is, you could statically build that and just toss it on whatever bucket you need. Put it on s3.html file like the pioneers did it. And when you need to add interactivity, like a like button to your blog, you can load JS and control when that JS is loaded. So in this case, we are adding a client directive to only load the JavaScript when a condition is met. Here we want to make sure the client JavaScript only loads when that component is visible on the page. So if it's below the fold in some way, like it's below the hero banner and the title, we want to not load React up front. Like maybe you're using React for this component. We can avoid loading it when you initially go to the web page, so you get that really fast response time and really quick, tossing into the blog post. And then when you start scrolling down and you need some more features like the like button, it will mount React, it'll mount that component, whatever dependencies that it has, and then that JavaScript is added to the page. So this, again, addresses our principles really well. So the lowest common denominator, static homepage with 0 JavaScript. We serve up HTML templates. There's no client-side routing baked in even. You can bring that yourself. It is keeping it as simple as possible. And the additive complexity is adding that client directive. You realize now I need JavaScript for this page. So you write the component, use the client directive. You're conscious of where that JavaScript is loading. Again, in those PR reviews, people know what you're doing. And it is user first. We're maximizing those core web vitals. If you don't know that term, it's kind of what Google has dubbed all of their metrics for a good website. So usually you want high core web vitals so that Google will index your page and it will put it higher on the search results. If it's able to index your page easily, you will probably get better SEO. And it also means faster load times for the user. It could mean time to first byte or time to interactive. So all of those are being maximized here. And you can measure those using Lighthouse scores and other performance monitoring tools. But the goal is to have a baseline that really addresses those well. So now I'll jump into a few demos with the time that I have left. Looks like we have about 15 minutes, something like that. Want to allow some time for questions, but I do have 2 demos that I'm going to try and share. The first one is around React server components, actually, which is the new wave of React. I think it does have some really nice examples of opt-in design. And also trying out an Astro site. So we're going to demo that like button. We're going to see how it works in a standalone blog so that you can, try it yourself. And feel welcome to follow along as well. All of this stuff is open source and available. So the first example I'm going to do is React Server Components. Here I have spun up a simple React Server Components environment. I've called it simple-RFC, RSC. And if you want to Google that, it really is just simple-RSC. This is a starter that I built that takes away Next.js, takes away all of the weirdness around React Server Components. It's in a really weird state right now. And it just shows you a raw server component. So what does it do? What is it going to load on my page? And how can I develop with it? So I've even deleted some of the starter code so that we just get blank slate so that we see what's going on. And in this example, I just have a server root component, and it's going to render this heading right here. So I'm going to spin up the dev server right now. Dev, there we go. And we have a server on localhost 3000. And let me pop open that tab. So this is, pretty bare bones. There's not a lot going on. And at the top, we see our heading. Of course, this is some static server components. And I also added a nifty little developer panel so that we can follow along with what React is doing, what it's shipping to the end user. And this is the default right now, where in React, instead of shipping a JavaScript bundle with all of your components information, it will stream down all of the elements to render on the page. So if you've used HTML streaming, this is kind of a more advanced version of that is React specific, but it is streaming down server information, which is a really cool sort of flip in how React has been working. This is now a way to opt into new behaviors. So the default in React is server render, stream to the client. And if we want to add some more content to this, like a paragraph element, hello, big tech day. If I put that down, now we see our paragraph coming in and it's added to our stream from the server. So pretty simple example. What if we want to get more complex? For example, we need to fetch some data from somewhere. Well, I've created an album viewer. That was the original intent of this demo. And I've created a simple database function that will get all of the albums. So in React, what you can do nowadays is run await inside of your server components. So you can think of these like backend functions that return templates, like Express and Jade. You did those authentication flows and then returned a template. In React, it's almost the same principle. So in here, I'm going to do a database call. I'm going to await the result, and then I'm going to render out some albums. And we're going to rely on Copilot to get this working fast for us. There we go. So I'll create a div. I'll create the title, maybe the artist, and I'll close off that div. That should be good. And we are getting an immediate syntax error. Unexpected token. Have I done something wrong? Oh, I definitely have. There we go. I don't know why I did that. There we go. So we're returning our albums and we're rendering them out to a list of artists. And we can render that component like any other component. Even though it has a weight, even though it has a bunch of weird stuff in it, we can render out all of our albums. So this is going to render all of that. Let me double check what I did here. I think I crashed my server because I wrote bad syntax. There we go. So if we check this out, now we're listing all of our artists. And we see in the server stream, it's going to stream down all of the elements that are needed to render those artists. And it's not going to send down the full JSON blob. This is something web developers have dealt with for a long time, where you made those REST calls, you got back a huge blob of data from whatever backend that you have, and you throw away like 90% of that JSON blob and just use 10% of it for your purposes. This is why GraphQL emerged. This is why, well, it's really just GraphQL. It's why that technology emerged, is you wanted to be smart about what objects are coming down the wire. But now in React, because you can stream the results directly, you don't even need GraphQL to be smart about client bundles. Now it's only going to stream down the HTML that is rendered from that data. So we can add some complexity to this. We can add an image if we want to. We have our cover right here. If we do that, it's going to add in our album covers to this server stream. But you'll notice these image URLs only came down when I rendered the cover. So this is the most bare bones example of opt-in I can think of, where you're opting into the individual bits of data and HTML that are needed for your application. So now let's get a little bit more fancy. one thing that's going on right now is we are going to block on rendering our components until every promise has settled. So in here, I've created an artificial timeout in order to make it feel like, a kind of slow query. Let's make it really slow. In this example, now it takes a full second for our full page to render. And maybe you're relying on a third-party API. You can't control the speed of it. So you have to work around this restriction where you only have that 1 second delay, but you still want to get as much to the user as possible. So in this example, it would be nice if we could render, the heading and whatever other information we have and stream in the album later. As soon as it's ready, show off the album list. But until then, at least show a nice header, maybe some other information. And that is where suspense comes in. And this is an opt-in to HTML streaming for parts of your application. So what I've done here is I have told React to show a loading fallback while this component is resolving. And then when it's ready, show the album. And it's going to be smart about seeing the promise here, showing loading while that promise is resolving, and then it'll stream in the result as soon as it's ready. So we see there, if you look at that again, we see Abramix shows, loading, and then the component. And that's the beauty of having an open stream, is that you can break up that stream depending on what is available when. So now we're not going to block on rendering. We're going to send down everything that we can, including this loading spinner here. And then React is going to have a bit of client-side JavaScript to smartly replace this loading spinner with this stream that's coming down from the server. And it is as simple as matching up numbers. So you see here the children L3, it's going to wait for the number 3 to come down from the server, and then it'll take whatever comes down on that stream. So nice opt-in to more complexity. Loading spinners have layout shift. They have other implications that you need to understand. That's why it's not the default in React. But as soon as you want it, you can add that complexity if you need to. Pretty cool. Now, the last opt-in that is worth showing in React is client-side JavaScript. And this is, something that is missing from a model right now, where we've only been rendering React as a server templating language in a way, or a server streaming language. So I'm going to back up to the full demo that you can find on the open source repo if you search for simple RSC. This is something I got to build with Dan Abramov, a core member of React. So I'm really happy with how it turned out. But this is a search box that's able to search for albums and stream in results from the server whenever you input on that search box. So I'm going to pull up that component here. You notice at the top, it has this use client decorator. And this is our opt-in switch. This is a way to tell React this component needs to ship to the client wholesale. It's not going to run on the server. It's going to maybe server render, but it's going to execute all this logic on the client. And we need that because we need to track the user's input. We need some client-side JavaScript to do that and to trigger fetches with a debounce if you want it in order to show those results as they come in. So you notice here we get a nice loading indicator loaded with client-side JavaScript, and it's going to stream in the server results every time you type. So you see the client import, which is just a JavaScript import, and then whenever you type, a new server stream comes in with those new results. And you can see all of that sort of streaming down here. So there you go. If you also need client-side JavaScript, that's again an opt-in switch, but the default is some nice static server-rendered HTML. So there we go. 2 examples of really good opt-in design. And now I'm going to switch over to Astro to show how that framework approaches the problem. Because if you say it's a new wave of frameworks, you better come prepared with at least 2 examples, right? We've been through many, but I do think that code demos are the most effective way to do this. So actually, I'm going to spin up a new project from scratch. This is something that is very dangerous to do in a demo, I'm aware, but we do have an online sandbox that we can visit if we need to. So if you want to follow along at home, you can run Astro.new, or you can go to that website actually, and that will have a bunch of templates that you can try out. Or you can pop open your terminal on your laptop and run the CLI command. So if you want to spin up a new Astro project, you can use our create Astro helper. And it is simple as npm create Astro, put an @latest on there to make sure you get the latest one. npm's weird. And you can also specify templates among other things, or you can just let the CLI do it for you. So I'm going to do that, and you'll get our beautiful little Houston robot to tell you, I'm your assistant. I'm going to help you set up this project. So I'm going to set up this big tech demo. I'll call it Big Tech Demo. We'll include the blog template, perhaps, since we want to play with some existing stuff. You can also get some default styles or an empty project if you prefer. This will install with, I'm using pnpm, which is npm but faster. If you want to use it, it's definitely my recommendation as an open source JavaScript person. And we'll also initialize a Git repository, use TypeScript, which is built into Astro by default, and we can pop that open in our VS Code. So I'm going to use code recursive to open in our current window. And what do we call this? I think we called it Big Tech Demo. So we pop that open. Yes, I trust the authors because I'm the author. VS Code is very cautious. Again, opt-in design. There you go. Opt-in to file system access for certain projects. There you go. It's everywhere. But when you set up a blog starter, that's what we have here. It comes with a few things that you will need. First off, the list of content, which contains all of the Markdown or MDX, MarkDoc. All of my favorite content formats are supported here. We also have our layouts. We just have one. We have our pages, which is file-based routing. If you're familiar with that, that's what Astro uses. And we also have some styles and other things in order to make it look nice. So if I want to spin this up, it's again dev, pnpm dev. And this will spin it up on 3001. I think we have that other port still running, but that should be fine. So let's jump over to 3001 right here. And this will show you a very bare bones blog starter. And we have an index of all of our posts. We have them rendered out right here. And the beautiful thing about all of this is that it will only render static JavaScript. I was in the wrong key there, but let me go ahead and do a build because builds are very quick when you're just working with static content. And I'll preview that so that you can see how much JavaScript is being shipped without all of those dev server tools. And in this preview server, I'll head over to network. We'll look at JavaScript. And you'll notice JavaScript's empty. There's no JS on this page. Even though we used MDX, even though we used component languages to build the UI, the end result is just a static page with absolutely nothing on it except HTML and CSS. That's all we're working with. And that is Astro's sort of like really aggressive opt-in principle, where all JavaScript is assumed static and server side. Not even React server components do this. And if you want to add it, you need to be conscious about the component library you're loading and use client directives in order to add it. So I am going to demo that opt-in behavior, actually. I'll start up our dev server again to show you what that looks like. And over here, I'm going to collapse that, I'm going to hide our sidebar, and I'm going to hop over to our index page. This is using a wildcard route to generate all of our paths from our Markdown files. And say I want to add a like button to this page. So we probably want to wire it up to the network and save it to a database. For now, I'm just going to use a client.js solution in order to store the state of liked somewhere. And I'm going to do that using React. So right away, I'm going to stop the dev server, actually. I'm going to run Astro add React. And you can also run Solid, that cool library I just demoed, Svelte, Vue, Lit Element, any component library that you're aware of should be supported. But I'm going to jump into React since it's the most popular. And that will add all the dependencies for you. It will update your config and it'll update your TypeScript configuration as well so that you can work with JSX without having to look through some docs. So opt-in, it's a good principle, but it should also be fun. It should also be something developers can use when they need to reach for it. Because we know opt-in JavaScript is tough. It's a new mind shift. So we want to make it very easy for you. So if I want to add a component, I'm just going to hop over to components. You can use whatever name you want. We just use components. It's everyone's favorite. And I'll create a React like button. So I'll use a template. We'll create a like button. And we're going to store the state of liked somewhere in here. There we go. And we will import that from React. We'll create a button in order to update that state. On click, we're going to set liked to its opposite. So this is going to be a toggle button, not liked. And then we want to render out that you like this or like this. I'm just going to use a emoji for this. I like using a hollow or white heart emoji when you haven't liked it. Or actually, that's the opposite, isn't it? So this is when you haven't liked it. When you have liked it, we're going to do a filled heart. So we have a basic component here. I'm going to export it so I can use it in my other files. Now that I have that, I can hop back over to my template. I'll go ahead and import that like button. Components, like button. Copilot wants to get a little crazy there. And now we have our like button. We can import it at the top using plain JavaScript syntax. You'll notice we have these little backticks here. This is the wall of JavaScript that's going to run at build time or on server render. So this is not client-side JavaScript. This is server JavaScript. Think of it like an express endpoint where you can do all of your logic and return a beautiful template at the end. But in Astro's case, we support JSX, component, syntax, all of the modern stuff. You're not working with old school nunjucks or Pug or any templating language you might have dealt with, like Django templates in Python. That's a common one. We like to use JSX around here. So I'm going to add my like button. Let me put it a little higher on the page. And we see it render out here. Server renders by default. But you'll notice when I click on it, nothing happens. That's because in Astro, again, we need to opt in to client-side JavaScript. It's going to be a server template by default. And you can use client in order to do this. I demoed use visible a little while ago. I'm going to use load here, which means load it as soon as possible. It's above the fold. I don't want to delay JavaScript if I know it's always going to be there. So if we do that, now we've mounted React and our like button is fully functional. So there you go. Opt-in client-side JavaScript. And we also have opt-ins for server rendering, all sorts of other tools. Astro Add is your friend in order to opt into whatever complexity your app needs. So there you go. Those are my two tech demos that I wanted to walk through. And it looks like I nailed the timing, absolutely nailed it. Hope y'all were able to follow along since I did go through quite a few things. But thank you. Thank you for having me. And we'll totally open it up to questions. If you want to get involved with Astro, you can join our Discord, Astro.build/chat. That's where you can submit support requests, share what you're building in our showcase channel. A lot of ways to get involved. We're friendly. And if you want to find my stuff, I do a lot of demos, including on this whiteboard here, a much bigger one back at home. You can find me at wtw.dev. I have my full YouTube archive over there. Every video is 60 seconds long, so if you want a taster, it just takes 60 seconds. And I try to teach React Server components, Astro, all the terms that might have gone over your head in this talk. You can head over there and get a full summary. And this slideshow is also on my GitHub. bholmesdev is my handle everywhere, including GitHub. So head over there if you want a recap of everything that we did. All right, thank you. I guess I'll open it up to questions now. Can't hear your applause, but I appreciate it. Thank you.
So thank you very much for this inspiring talk. I hope you could hear the applause here. It was quite loud. So are there questions?
Hello, thank you for the nice talk. It was inspiring. As someone who doesn't have much experience in React and similar libraries like that, frameworks like that, I'd like to know how this whole opt-in design thing works or plays with Angular, for example. Can you comment on it? Thank you.
I can. Yeah, Angular is kind of that one lost voice that I haven't played with in a while, but they have been doing some interesting stuff recently around opt-in design. They released observables. I know that that's their new state management paradigm. So instead of using templates and I'm trying to remember how it worked. I remember when it was Angular 1 and you used $scope. But I know that their state used to be a little bit wasteful. They did a diffing algorithm kind of like React. But these days they use observables, which are similar to Solid and Svelte, the two that I demoed, where whenever you update a state value, it's going to just update the part of the template that relies on that state. So you can, have a stateless web template by default if you want to with server rendering. I know that they bake in server rendering now too, which is great. And if you need state, it's now much more granular in how it does those updates. So I feel like that's the one echo from the other libraries that's made its way to Angular. And now they're very involved with other framework maintainers like Solid, like Svelte. They're using Vite as their bundler, I believe. They've been working on that for a while, but it's not quite here yet. But all of that's pretty promising to me. It feels like they're definitely part of the conversation too.
Further questions? Maybe I have a short question. What are the drawbacks of opt-in design, maybe?
Yeah. Well, it really depends on just how much you have to opt into, because developers are a finicky bunch. We want to get things shipped with the fewest Jira tickets possible. And if you need to install, 10 plugins in order to get the dashboard app that you're trying to build, then it feels like I wish I just started with the kitchen sink. I wish I started with everything. And that's why, opt-out mindset exists, is you want everything to be available so that you can get running faster. So I feel like it depends on how the opt-in's implemented. In Astro, for example, we recommend it for content sites a lot because people benefit from that low JavaScript HTML. But if you're building the next Facebook, Astro is going to be really annoying because it has all these opt-in switches to do everything that you just need by default when you're building Facebook. Everything's interactive. So at those points, you need less opt-ins and more just like baselines. So it's kind of going back to the car with opt-in wheels where people drive different cars. It might need a lot more built in for what you're trying to do. So you really have to be smart about, setting those defaults and auto opting in depending on the use case that you're targeting. We target content, but if you're targeting apps, I do think it's smart to turn those switches on by default instead of off.
So hi, maybe one question in the same general direction. How do you think it affects the learning curve? So basically, if you have an opt-out library that strips everything per default, so everything is in there, whereas an opt-in, you every time you need something, you need to learn about it.
Yeah, I mean, some of that gets down to philosophy. There are some people who think, you have to use NeoVim for everything because you need to learn how editors work. And other people think just use an IDE. Who cares how the computer works? Just get something on the page. I personally learned programming through Java at first, and then went into React, and then started learning about more of the base. So to be honest, I did start with a lot of things decided for me. And then when I started to sort of mature in my career, I started looking behind the curtain and opting in more intentionally. So I feel like it can depend on how you like to learn things. I think if you're building a production app, then it is smart to force people to learn things with all these opt-in plugins because they know what they're shipping. They know the performance that they can get out of all of their tools so that they don't shoot themselves in the foot and ship a really big JavaScript bundle. So I do think that we need a bit more of that mentality, especially in web dev where payloads are very sensitive. But if you're just learning and you're not shipping production apps, you're just building weekend side projects in order to learn the technology, it might be okay to, not worry about any of those switches and just download a template from GitHub that has everything flipped on for you. That's always an option. You don't have to start with the template that comes from Create Astro. You can download a theme that charts the path that you're already going to go on, that made all the opt-in decisions for you so that you can just get going. But I do think if you're building production tools, you do want to know what switches that you're flipping on because you have to learn them at some point and you want to learn them at the right time.
So I think we don't have any further questions. Also Slack, I think, was no question. Okay, then Ben, once again, thank you very much for this talk. Maybe next time in Munich as well, so if you have time. And I wish all the other people have a nice evening program, enjoy your dinner, and I think, Ben, enjoy your lunch. Also on your
Yep, I got to hop to my morning meetings. Sadly, I wish I could just be in Germany. I've never actually been to Germany, so I hope for a warm welcome if I ever come back. But y'all been great. Thank you.
Thanks a lot.